Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper trending on X, published on October 22nd, 2025, about 3 days ago. The big idea is to model the future with language by asking action-conditioned questions, which delivers striking results like 100% success on laying table, reaching, and separation, and 97% cube reaching on OG bench. The paper is titled Semantic World Models, and as we'll see later, the implications for planning and data efficiency are quite significant. In short, a pre-trained vision language model answers future-focused questions to score action sequences, enabling both sampling and gradient planning with strong generalization. Alright, the previous segment set the motivation for predicting future semantics. Figure 1 contrasts 3 options. A vision language model answers questions about a single image, which is like saying the flower is pink. A video world model predicts future frames from an action sequence. The semantic world model instead takes the current scene and proposed actions, then answers outcome questions directly, so it returns yes or no to prompts like will the peg touch the green block. So figure 1 contrasted modeling choices. Figure 2 shows the full pipeline, with the graphic summarizing how a semantic world model scores and improves an action sequence. The left side presents the current observation, the proposed actions, and natural language questions about the future, which define what success means. The right side runs these through the model to produce yes probabilities, then adjust the actions to raise task value, so the desired answers become likely. Well, Figure 2 outlined how actions get scored. Figure 5 reports the payoff in success rates. The bars show consistent gains, with the yellow semantic world model topping gray base policies, pink offline reinforcement learning, and blue video plus question answering across tasks. The left side covers language table, where averages rise to about 82%. The right side presents OG bench, where performance climbs to roughly 76%, with error bars indicating 95% confidence. So the previous figure summarized overall gains. Table 1 presents multi-step results on 4 compositional tasks, where each task chains 2 language goals, like moving a red pentagon, then a yellow pentagon. The base policy and the video plus question answering baseline stay in the single digits, while the semantic model jumps to about 50 to 66% across MS1 to MS4. The results use 50 seeds and report 95% confidence intervals. Alright, the previous table highlighted compositional gains. Figure 8 presents the architecture, which routes images, actions, and a question into a single language model so it can answer yes or no about future outcomes. A contrastive vision encoder feeds embeddings through a linear projection. The action sequence passes through its own projection, while the question is tokenized. These streams form one token stack that the Gemma 2B transformer decoder processes, producing a semantic answer. So, Figure 8 covered how inputs flow through the model. Table 8 presents the resulting success rates across planning tasks. The semantic model leads across the board, beating the gray-base policy, offline reinforcement learning, and the video plus question answering pipeline. Push tasks land around 78 to 86%, while stack tasks reach roughly 62 to 84%. Results use 50 seeds with 95% confidence intervals, so differences are statistically meaningful. Okay, 2 takeaways stand out. Predicting future semantics with action-conditioned questions aligns the model with decision-making, and that alignment delivers big gains in planning success and generalization over video reconstruction and offline reinforcement learning. The broader implication is simpler, more data-efficient robot control by leveraging pre-trained vision language models. That is it for the AI Research Roundup. I am Alex. Thanks for listening.